Hi, everybody. It's Professor Mitchell. We're continuing with Chapter 4, and today we're looking at Section 4.2, Solving Systems of Linear Equations by Substitution, which is our only objective in this section, and we are continuing to work on SLOB, which for this chapter is Solve Linear Systems. So remember in the last section, we talked about solving systems of linear equations by graphing. So this will be the second method for solving systems of linear equations. We'll have one more in section 4.3. All right, so to solve a system of linear equations by substitution, here are the steps. Take one of the equations. Remember, there will be two. And solve one of the equations for either x or y, whatever's easiest. You will usually have four choices. Label the new equation with a star. This is a system that I like to use. Use this equation to make a substitution in the other equation. This is very important. So if you start off by solving the first equation for y, you need to then make the substitution in the second equation. All right, and then solve the equation from step 2 to obtain the value of one of the variables and substitute this value into equation star to get the value of the other variable. And then remember, it's always a good idea with these systems of equations to check the solution in both equations. That is really strongly encouraged when you solve the system by graphing, but it's still encouraged when you do it some other way. All right, so after this, we have, I believe, 4 examples. So I am going to switch over to the tablet, and then I'll just stay there. The directions in each problem will be solved by substitution. All right, so I decided to start with this example because I think it's the easiest. We have y equals 3x plus 2 and 7x minus 4y equals 2. The reason I'm starting with this example is because the first equation is already solved for y. So that's like the best case scenario. Solved for y. All right, so since that equation is already solved for a variable, I'm going to label that equation with a star, and we will come back to that later. All right, so now I'm going to take the other equation, 7x minus 4y equals 2, and I'm going to substitute 3x plus 2 for y. See, the first equation says that y equals 3x plus 2. So that means we can replace y with 3x plus 2. So lo and behold, we have an equation that is only in terms of x, and we are experts at solving this kind of equation. I'm going to distribute the negative 4, which is going to give me 7x minus 12x minus 8 equals 2. Combine the like terms. 7x minus 12x is negative 5x. And then add 8 to both sides. That gives me negative 5x equals 10. And now I'll divide both sides by negative 5. Turns out that x equals negative 2. All right, so we have x. Now we just need y. The reason that I recommend substituting this value into the star equation is because the star equation will always be solved for the other variable. So star equation is y equals 3x plus 2. So if I substitute negative 2 for x, I get y equals negative 6 plus 2, which is negative 4. All right, so since x is -2 and y is -4, that means we think the solution is -2, -4. I will check that solution. Remember to check it in both equations, starting with y equals 3x. It is +2, right? Yes. Okay, so if I substitute -4 for y and -2 for x, I am wondering if -4 is equal to 3 times -2 plus 2. Well, 3 times -2 is -6. -6 plus 2 is -4. So it works in that equation. But we also have to check it in the other equation, which is 7x minus 4y equals 2. All right, so now substitute -2 for x, -4 for y. We get 7 times -2 minus 4 times -4. We want to know if that is equal to 2. Well, 7 times -2 is -14. -4 times -4 is +16. And sure enough, -14 plus 16 is 2. This equation also checks. Woohoo! It checks in both equations. This is the correct solution. All right, the next example, we're solving by substitution. 3x plus y equals -14, and 4x plus 3y equals -22. So in this case, neither one of the original equations is solved for either x or y. So I want you to spend a few seconds thinking about what is the easiest choice. Should I solve the first one for x? Should I solve the first one for y? Should I solve the second one for x, or should I solve the second one for y? Which one of those choices would be the easiest? So hopefully you said solve the first equation for y. And the reason that's the easiest is because that y is the only one that doesn't have a coefficient on it. So all it takes to solve this for y is to just subtract 3x from both sides. So that gives us y equals -3x minus 14. Going to label that equation with a star. And since that equation came from the first equation, we need to make the substitution in the second equation. So from this point on, this is pretty similar to the last example. Okay, so we have 4x plus 3y equals -22. I'm going to take out this y and replace it with -3x minus 14. So we have 4x plus 3 times -3x minus 14 equals -22. All right, so I'm getting ready to flip over onto the next page, where we're going to have 4x minus 9x minus 42 equals -22, right? So let me see if I remember all that. 4x minus 9x minus 42 equals -22. Let me just look back one last time, make sure that's correct. I'm pretty sure that's correct. So now we'll combine the like terms. 4x minus 9x is -5x. And now we'll add 42 to both sides. And that's going to give us -5x equals 20. Divide both sides by -5. We get x equals -4. All right, so we have x, we need y. So now I'm going to substitute this value of x into equation star, which is y equals -3x minus 14. So y equals -3 times -4 minus 14. -3 times -4 is +12. 12 minus 14 is -2. All right, so I believe the solution is -4, -2. In the interest of time, I'm not going to check every single one of these, but I will try to remember to remind you to check it. Check it in both equations. All right, so let's go on to the next example. All right, example number 3. We're going to solve by substitution. 2x minus y equals -7. 4x minus 3y equals -11. All right, so consider your 4 choices for which equation to solve for which variable. And once again, I think the easiest choice is to solve the first equation for y. I don't want you to think that's always the easiest choice. I'm sure I have at least one example where it's something else. But this time, that's the easiest choice because all of the other variables have a number attached to them. The only thing attached to that y is a -1, and that's pretty easy to get rid of. So we're going to take 2x minus y equals -7. We're going to solve it for y. First, we'll subtract 2x from both sides, which gives us -y equals -2x minus 7. But now we have to get that -1 out of there. So let's divide everybody by -1, and that's going to give us y equals 2x plus 7. All right, so again, from this point on, it's very similar to the previous examples. In fact, if you haven't done this already, you should pause the video and try to complete this problem. Come back and compare notes. All right, so I think I will go ahead and flip to the next page where I will write 4x minus 3y equals -11. And I'm going to replace y with 2x plus 7. Distributing the -3. We get 4x minus 6x minus 21 equals -11. 4x minus 6x is -2x. And then adding 21 to both sides, we get -2x equals 10. And we divide both sides by -2, and we get that x is -5. All right, so now we'll finish it up by putting that value into equation star, which remember was y equals 2x plus 7. When I replace x with -5, I get y equals 2 times -5 plus 7, which is -10 plus 7, which is -3. All right, so x is -5, y is -3. The solution is -5, -3, and of course, that should be checked in both equations. All right, so now on to the last example. All right, the last example is 1/4 x minus 2y equals 1, and x minus 8y equals 4. So one last time, consider your 4 choices. Should we solve the first one for x, first one for y, second one for x, or second one for y? Well, this time, the easiest choice is to solve the second equation for x. All right, because it doesn't have any number attached to it. So I take x minus 8y equals 4, and I add 8y to both sides. Oops. And that gives me x equals 8y plus 4, which becomes equation star. Since that came from the second equation, we will substitute it into the first equation. And I think I'll do that on the next page. So the first equation is 1/4 x minus 2y equals 1. We're going to substitute 8y plus 4 for x. I'm glad I double checked because I almost said 8y minus 4. All right, now distributing this 1/4, I know fractions are not everybody's favorite thing, but this will work out nice. 1/4 times 8y, 1/4 times 4, and then all this stuff stays the same. Okay, if I put a 1 underneath here and 1 underneath here, 4 and 8 have a common factor 4. 4 divided by 4 is 1. 8 divided by 4 is 2. So this becomes 2y. These 4's just cancel out and leave me 1. Okay, and then something kind of strange happens. I go to combine the like terms, and what do you know? They just disappear. That doesn't usually happen. That didn't happen in any of the other examples. So that leaves us with 1 equals 1. So let's think about what that should mean. Of course, we know 1 equals 1 is true. It's always true, no matter what y is. So in this situation, well, the chapter 2 version of this was the solution to the equation. There was just one equation, was all real numbers. We talked about this a little bit in the last section. That is not the correct thing to say in this chapter. We have 2 equations that are in terms of x and y. If you were to graph these lines, the lines would be identical. So that situation is, so remember, this is when the equation is always true. That means there are infinitely many solutions. All right, and that's all there is to say about that. So I'm purposely leaving out an example with substitution where there is no solution. I want you to think about what do you think that will look like, and it will come up in the homework. Okay. Something you can always ask about in the discussion if you're not sure. But otherwise, that's going to do it for section 4.2, and we'll see you next time.